Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live today, you are welcome to call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available from me, the teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 11 till 12 in the morning, and we are now in week 7 of our 9-week course. At this point, you should be submitting work for marking. So a reminder what to submit. The support questions, the ones marked with a pencil icon, are not for marking. They're just practice. So please, you can decide which ones to do and how many of them to do, depending on your needs. If you're understanding a concept, feel free to skip questions. If you need more practice, let me know and I will find you some more practice. The answers are in the back, so check your work. However, some mistakes have been found. So if something's not lining up, let me know and I can make those corrections. And if you find something, maybe you found new mistakes as well. So just let me know and we can make those changes. The key questions, the ones marked with the key icon, are the ones to send in for marking. So please do all of those questions and show all your work, your steps, and your thinking. This way I can give you credit for all the understanding that you have, even if you do make a mistake. And also if you are struggling with something, it helps me understand why you're struggling so that I can help you understand. There are 3 different methods to submit your work. The first method is to scan and send your work in electronically. You can scan your completed work in. If you have a smartphone, you can use the iPhone Notes app or the Android Google Drive app. If you don't have a smartphone and you just want to take pictures, that's fine too. But then your work either through email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street, which is our the big red building next to the post office. And there's a small white mailbox next to our side entrance. We continue to be working remotely, so it may take me a couple of days to get it, but I'll get it back to you as soon as I can. You're working to your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Always, if you have any questions or concerns, if you're struggling with anything, you need more time or something, let me know. Email is probably one of the easiest ways to get a hold of me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. Or also connecting with me through Facebook I answer pretty quickly. My name there is bslatewahsa. You can call the main office and leave me a message there, letting me know when would be a good time to call you back. The number is 807-737-1488 or toll free 1-800-667-3703. Currently, my office hours are Monday through Friday, 8 a.m. to 2 p.m. And I will get back to you as soon as I can. Sorry, if you want to connect with me through social media, my Facebook and YouTube are both named bslatewahsa. So you can subscribe to my YouTube channel or friend me on Facebook. All of our lessons are uploaded shortly after airing, and they are uploaded into a playlist on YouTube, and I share them on Facebook. So that's a great way to access the replays if you'd like. There's also short videos explaining common errors or confusing concepts on my YouTube channel. So that can be a great place to go if you're struggling with an idea and check out there first to see if there's something that might help you. Math is a very visual subject, So connecting to the videos for the most success, either joining me live through Zoom or watching the replays on YouTube is really going to benefit you. If you don't have access to reliable internet, let me know and I can send you a USB key with all of the lessons. We're on day 26 of our course and we're finishing up lesson 17. Last session, we started with lesson 17, talking about measures of central tendency. And today we're going to be focusing on standard deviation as well as other measures of variability. So our learning goals for lesson 17, so both last session and this session, are that I will be able to distinguish between the mean, median, and mode averages, and I will understand the purpose of the range, variance, and standard deviation for a set of data. So I know I have met these learning goals because I can calculate the mean, median, and mode, and I can calculate the range, variance, and standard deviation. All right, let's activate our brain and do some mental math. Instead of doing mad minutes, which many of us experienced in elementary school, which were just anxiety provoking and not actually helping us learn anything, we focus on developing strategies that we can apply in different situations and get comfortable with numbers so that we're understanding what's going on opposed to just hopefully memorizing something. So our question today is 63 plus 66, and our strategy is near doubles. So this is not a double, but it's close to doubles, and there's various doubles that we could look at. As we know that doubles are numbers that are often fairly easy to remember. They just sort of click in our brains for many of us. So I know that this 63 is close to 65 and 66 is close to 65. So 65 plus 65 is 130, because 60 and 60 is 120 and 5 and 5 is 10, so that's 130. But I had an extra 2 to go from 63 to 65, so I need to take away 2, and I took away 1 to go from 66 to 65, so I would need to add 1. So really that just means I need to take away 1. So 130 take away 1 is 129. So 63 plus 66 is 129. So using that strategy of they're both being close to 65 and adjusting the numbers helps us get to that final answer. All right, mine's on. Let's engage in some prior learning and remember what we're talking about in terms of measures of central tendency. If you haven't watched the first part of lesson 17 video, you might want to go back. I'll link that in the show notes. If you're comfortable with measures of central tendency of mean, median, mode, and even if you didn't watch the other lesson, that's fine too. So the mean is when we add up all the data points and divide by the total number of data points to find that middle number that represents sort of the data. The median, we need to order our data points from lowest to highest, and then we find the actual middle value to represent the middle of the data. If there are 2 middle values, because there's an even number of data points, then we add those 2 middle numbers up and divide by 2 in order to figure out what's halfway between those 2 middle points. Mode is that we find the value that is the most frequent. So you may order your information from lowest to highest if it's numeric, but you also can just look to see what your most frequent value is. And it is possible to have more than one mode if you have multiple values that have the most frequency. All right, so that's what we need to remember as we move on. We need to remember those languages and those vocabulary so that we're going to activate this new learning and explore these new concepts of measures of variability. So we need to first understand why variability is important. So we often focus on the mean to summarize the center of a population or a process. And this is important, but how much the data varies is also essential to understand. So not just knowing where the middle is, but how much things are in relation to that, or how much data varies is important, because if everything is really close to that number, that means one thing, but if everything is spread out, that means something else. So a low variability means a more consistent data set. It means that all of your data is really close together. And a higher variability means the data points are more dissimilar, or extreme values become more likely. So it means that we have either our data is all spread out, or we have some really high data points or some really low data points that are inconsistent to the rest of the data. So understanding variability helps us to grasp the likelihood of unusual events. So if we have a low variability and it's really consistent, then most likely things are going to continue on that trend. If we have high variability, things are really varying, really different, then we know that it's more likely that different things are going to happen, that unusual things are going to happen. So we're going to look at 3 types of variability to understand different ways that we measure that. So the first is range, and this is on page 10 of your IL booklet. So range is the spread of your data from the lowest to the highest value in your distribution. So we subtract the lowest value, our lowest data point, from our highest data point. So let's look at an example. I gathered the age range. So it's asking, what is the age range of the students registered in MBF3C? So in our course, we have a range of ages. And so we're looking at, we have a bunch of data points of different people's ages, and we're looking at what the range of that is. So we have 21, 36, 31, 26, 20, 25, 34, 22, 28, 27, and 47. So the range, how we calculate this is that we look for the highest value, which is 47, and we subtract the lowest value, which is 20, and that gives us 27. So the ages of the students in our MBF3C course range by 27 years. And that's the straightforward how we just calculate our range. Now, good representation of data variation if you don't have any extreme values. But if you have extreme values, because we only have 2 points that are used, those outliers can really skew our understanding of the data. They can really change. If we have a really, really high value and a really, really low value, but the rest of our data is all clustered together, then that's not really going to be a good representation of what is actually going on. So if we, again, look at our age ranges of the students registered in our course, we see that we have a whole bunch of similar data points. We have 10 similar data points, which are between 20 and 36. So that's within 16 years. But then we have this one outlier of 47, which is great. But that is changing. Is different than the rest of our data points. So that skews our information a little bit to say that we have a wider range, when really we just have one person of that age, and the rest are more similarly clustered at a different point. So this distorts our understanding of the ages of people in our course. So the range is not the most common used, because it gives us a general idea, but not super accurate, precise information. So we can look, here's 2 graphs that have the same range, but have a really different distribution. So we have one graph that has one value for every point between 30 and 160. So 160 is our highest point, and 30 is our lowest point, which means that our range is 120. And for each of those points, we have 1. So 1 between 30 and 40, 1 between 40 and 50, 1 between 50 and 60, 1 between 60 and 7, continued all the way up to 160. So we have very, very even distribution. Then we have another graph where we have still a frequency of 1 from between 30 and 40, and a frequency of 1 between 150 and 160. So that means our range, our lowest point is 30 and our highest point is 150. So that means that we subtract and we get 120. Our range is still 120, but then we just have 1 between 40 and 50, and 1 between 110 and 112, and then 9 between 50 and 60. So our information is really, really different. This is not evenly distributed. We have a lot of information at one point, and the rest is sort of sparsely scattered about. So these are really, really different situations, though they have the exact same range. And so we don't get the same amount of information as that we would is really useful in terms of making accurate decisions about things. So the range is good to know, but we need to find some other things that help us understand a little bit more. So what is more precise? So variance and standard deviation are two types of an absolute measure of variability. You may have heard this language before, variance and standard deviation. Lots of times standard deviation is sort of thrown in, but it's hard to necessarily understand what these actually mean. So they describe how the data is spread out around the mean. So it's not just the highs and the lows, but it's figuring out what the mean is and then talking about the rest of the data in relationship to that mean. Similarities between variance and standard deviation are that they are both always positive. And if the data points are identical, then the standard deviation and the variance will both be 0. So if everything is the same, then there's no variance, there's no variation, so they both equal 0. The differences are that the variance means how far the numbers are spread compared to the mean average, and the standard deviation is the measure of dispersion of the data values from the mean. I've spent a lot of time trying to figure out the difference. It is at this level of statistics, it's a little bit unclear really how they are different. They're calculated slightly differently, but very similarly. So really they tell us how the data is spread out around the mean. They're not interchangeable, but they do give us a slightly different information. I think at higher levels of statistics, this is clearer. And at this point, we just kind of are just learning about how to calculate them without really seeing necessarily the purpose of both of them because they are very similar. So first we're going to look at variance, and this is on page 10 of your IL book. So again, the variance measures how far data points are spread out in the set of data from the average, which in this case, the average, we mean the mean. That's what we're referring to. So it's a numerical value that describes the variability of observations from its arithmetic mean. I've collected a few different definitions in order to hopefully that one of these click and make sense for you. It helps to determine the size of the data spread. So it's expressed in larger units than the data. So we were just talking about age was our example, and variance would be age squared, which doesn't really make any sense to us, but variance is always squared units opposed to the units of the data, and that is the key difference when we're looking at variance and standard deviation, how they're really different is that variance is always very large. It's quite large in comparison to what your data is. The notation is sigma squared. Sigma is a Greek letter that looks like a little O with a tail, or S squared, depending on if you're looking at population or sample. It doesn't really matter for us. The variance notation at this point, we can just use sigma squared or S squared is fine. We're not going to be too nitpicky about that. So how do we actually solve for the variance? We know that it is comparing the spread of data to the mean, but how do we actually figure it out? So let's look at the variance of the student ages in our class again. So we have a list of our ages, and these are the steps to solving for the variance. So step 1, we need to calculate the mean of the data. We need to figure out what our mean is so that we can compare all the rest of our data points to it. So our mean, we know that we add up all of our data points, and then we divide by our total number of data points. So we have 21 plus 36 plus 31 plus 26 plus 20 plus 25 plus 34 plus 22 plus 28 plus 27 plus 47, then all of that divided by 11. So our mean is 28.8. That is our mean age for the ages of our students in our class. So then step 2 is that we need to calculate the difference from each data point to the mean. And so one way that's really easy to do this is to set yourself up a chart and like a table so that you have one column are your ages, and then we're going to organize our information to keep track of what we're doing because it's a bunch of calculations. So we have our first column is all of our ages, just listed in the order that we have them. It doesn't matter what order they're in. And then we're going to have a list of the mean, which is the mean is the same for each and every one of those data points, because the mean for the general data set. And then we're going to calculate the difference from the mean. So difference helps us, indicates that we're subtracting, right? Where the difference between two numbers, we figured that out by subtracting. So we do 21 take away 28.8, and that gives us negative 7.8. And then we do 36 take away 28.8, and that gives us 7.2. Then we do 31 take away 28.8, which is equals to 2.2. 26 take away 28.8 equals negative 2.8. 20 subtract 28.8 equals negative 8.8. 25 subtract 28.8 equals negative 3.8. 34 subtract 28.8 equals 5.2. 22 subtract 28.8 equals negative 6.8. 28 subtract 28.8 equals negative 0.8. 27 subtract 28.8 equals negative 1.8. And 47 take away 28.8 equals 18.2. So that's our second step, is to, for each one of our points, it's annoying, I know, but each of our points find the difference from, in comparison to the mean. We need to figure out how far each of the points are from the mean. So then our step 3 is that we square each of the differences. So still in our chart, we're adding another column. We have our ages, we have our mean, we have our difference from our mean, and now we're going to have our squared difference. So we're going to take each of those values that we just calculated and we're going to square them. So for age 21, the difference from the mean was negative 7.8. So we're going to square negative 7.8 and we get 60.84. For 36, the difference was 7.2. So we're going to square 7.2. So the square difference is equal to 51.84. The ages at age 31, the difference was 2.2. So squaring 2.2 equals 4.84. From the age 26, the difference from the mean was negative 2.8. So we're going to square negative 2.8, which gives us 7.84. For the age 20, the difference from the mean was negative 8.8. So we're squaring that and we get 77.44. The difference from age 25 to the mean was negative 3.8. So square that and we get 14.44. Age 34, square the difference from the mean, which was 5.2. So squaring that is 27.04. Age 22, the difference from the mean was negative 6.8. So square negative 6.8 and we get 46.24. For age 28, the difference from the mean was negative 0.8. So square negative 0.8 and we get 0.64. The age of 27, the difference from the mean was negative 1.8. So we square that and we get 3.24. And finally, for age 47, the difference from the mean was 18.2. So we square 18.2 and we get 331.24. So again, I know it's tedious. This is why using a chart can really help keep yourself organized so you don't miss any of your points. Yes, and you don't necessarily have to write all of it out. You could just do it on calculator and write down your numbers, your final numbers. You need to figure out what makes the most sense to keep that information tracked and clear. Again, if you don't write down everything, if you make a mistake, I can't see where you made the mistake. I don't know. If you write down your work, it's easier for me to find your mistake if you make an error. All right, then step 4, we need to find the sum of the squares. So we take all of our squared values and we add them up, and that equals 625.64. So that is the sum of our squares, all of those points. And then step 5, we divide the sum by the number of data points minus 1. So we take 625.64 divided by 11, because we have 11 ages, 11 data points, take away 1, which is equal to 62.564. So that's what our variance is. So those are our 5 steps. It is a little bit tedious to do all of that work, especially if you have a large data set. This is why we have computers to do lots of the math for us. But at this point, we're just doing it by hand. So you have to be really careful that you're not missing any numbers, or that you're paying attention to your what's going on and that you're tracking really carefully. It's really important that you're subtracting, that you're doing your data points minus 1, so we get more of an accurate representation. If we don't subtract that one, then it's not as accurate because we're just looking at a sample. So it's just important to remember that you're doing your data points, take away one. That's how we calculate the variance. So here's looking at two graphs, and we can see, just to sort of visually compare what having a high variance and a low variance is. It's kind of hard to know with our point if 62.564 is a high or low variance. I mean, it's higher than our values, but that's what we expect because variance is always going to be higher, significantly higher than our values because it's a squared value. But it's kind of in relationship that we can compare, but just having it on its own makes it harder to understand if this is a high or low variance. But looking at these two graphs, we have one graph with a really high value. So that means that something is benefiting greatly because it has a high, we're saying that this is having a high value is great. And then we have a really low value. And so others are not benefiting greatly. And then everything's kind of else is sort of in between, but it's sort of still spread out. And this has a high variance. There's a lot of variability in this graph and this representation of this data. And so that has a high variance. This other graph, where all of our data is closer together in the middle, we can see that this is a consistent benefit. Everybody's sort of getting the same. Yes, there's always going to be a little bit higher and a little bit lower, but generally it's all in the same area. And so this would have a low variance, a low variability, because all of our data is clustered around the same area. But again, you need sort of have other things to compare it to know if our 62 is a high variance or a low variance. All right, so now we're going to look at standard deviation, which again is on page 10 of your IL book. And standard deviation is the standard or typical amount that data points deviate or differ from the mean. So we're still comparing to the mean, and we're sort of relating it back to that. So it measures how much data points differ from the mean of the data set. Again, having a couple of different definitions to help make sure that it makes sense. A measure of the dispersion of data points relative to their mean. And it is the square root of the variance. So you still need to calculate the variance for the standard deviation, and then you take the square root of that number. It's expressed in the same units as the original values. So it's not in units squared, it's in meters or minutes, depending on what your original data points are. For our example that we're using with, our data points are ages. So our standard deviation would be in years, whereas our variance is in years squared, which doesn't really make sense. And the notation is sigma or S. All right, so the steps for solving for standard deviation. Again, looking at what is our standard deviation for the ages of our class, the students of our class. So we still have all the same data points. Our step one is to calculate the variance. I'm not going to go through it again. We just did it. So you have to go through those 5 steps to calculate the variance. So we have that from our previous example. So our variance was 62.564. And we got that from using that table. And then step 2 is we take the square root of the variance. So our standard deviation is equal to the square root of 62.564. So our standard deviation is equal to 7.8, which is approximately 8 years. So that helps us a little bit understand that our class, most people are within 8 years of our middle age, is what the standard deviation is telling us. So we remember our mean is 28.8. So our middle age of our students is around 29 years, and everyone else generally falls in with around 8 years of that age. So that tells us a little bit more opposed to our range, which we said our range was 27 years, but that didn't really tell us that most people fall where they fall, their ages fall around. So here's a graph of a standard deviation that shows that these, so this blue line has a small standard deviation. It says here it's 5. And as you can see, it clusters all around the same, all of our information is fairly clustered around the center. So our mean for all of these three graphs is right along the middle. And here, having a low standard deviation means that most of our data is clustered very close to that mean. Whereas the red line is a standard deviation of 10, so a little bit higher variance, higher standard deviation. And we can see that our data is being more dispersed. It's not clustered around the mean quite as much. And then the standard deviation, the green line, which is standard deviation of 20, we can see it really doesn't cluster around that mean very much at all. And so our graph is really quite low, and our data is dispersed very widely along and not very clustered around the mean. So that's how standard deviation can look on a line graph, to sort of see how close your information is all together. All right, so you can do the support questions now on page 11. It's question number 5. Pretty much it's just asking you to calculate the range, variance, and standard deviation. So you need to go back over those steps and really make sure you're doing all of those steps. All right, let's do a consolidation and then do some practice. So for lesson 17, today we focused on the standard deviation. So the measures of central tendency we did previously. So we talked about range, which is the difference between the lowest and the highest values, and outliers really distort the accuracy of that information. The variance measures how far data points are spread out in a set of data compared to the mean. They have squared units, and it's the sum of the squares of data points distance from the mean divided by the number of data points minus 1. There's really not a nice way of saying that. I tried to think of how I could write that out really clearly. I didn't want to introduce how we write it out with math notation, because then we start introducing other symbols that we haven't experienced yet. So that would just be more confusing. But really going back and doing all of those steps, that sentence just summarizes all of those steps, but doing the 5 steps is really going to set you up for success for the variance. And then the standard deviation is a typical amount the data points differ from the mean, and it's in the same units as the original data, and it's the square root of the variance. So our criteria for lesson 17 were that you can calculate the mean, median, and mode averages, which we did at last lesson. And then now that you can calculate the range, variance, and standard deviation. Hopefully with some practice, you can do that. All right, let's do some practice questions so that we can see this in action again. So number 1, Carmela's monthly gasoline expenses in dollars for the past year are shown. So we have 61, 83, 77, 88, 67, 71, 68, 72, 67, 84, 90, and 80. This person must not drive very much. Fills up their gas tank once a month. So A, we need to calculate the range to the nearest dollar. So in order to calculate the range, we need to have, so remembering that range equals highest, take away lowest. So we can order our data, or we can just look, okay, so here 83 is our high, 88 is higher. Nothing's higher than 88 yet. 84, 90. 90 is our highest value. And then looking for our lowest. So 61 is our lowest so far. 67, no. 65, no. 67, no. All right, so then 61 is our lowest value. So this is very similar to some of our strategies. We can think, okay, well, 90 take away 60 is going to be 30, and then take away 1 more is going to be 29. So our range is $29, or Carmela's for the monthly gas expenses. So it really ranges. So then for part B, calculate the variance to the nearest degree. All right, so first we need to calculate, so step 1 is to calculate the mean. I'm not going to write it all out just for saving space on my screen. But we know for the mean, we need to add them all up and divide by their total number of points. So we have 61 plus 83 plus 77 plus 88 plus 67 plus 71 plus 65 plus 72 plus, sorry, just moving my calculator, 67 plus 84 plus 90 plus 80 equals 905. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Assumed it was 12, but just want to check. So it's 905 divided by 12, which is equal to equals 75.4. So to the nearest dollar, so we're just going to say 75. We're not going to worry about the decimals. Okay, so our mean is 75. So now we need to, so step 2 is the finding the differences from each point. Now, I don't have a chart. I didn't draw in a chart here. So what I'm going to just do is I'm going to write it below. So 61 take away 75. I'm just going to write what my differences are here. Maybe not the best system, but for the sake of time, that's what I'm going to do. And I'm just going to subtract on my own calculator instead of changing to decimals. So we have negative 14. The difference between 61 and 75 is negative 14. The difference between 83 and 75 is 8. 77 take away 75 is 2. 88 take away 75 is 13. 67 take away 75 is negative 8. 71 take away 75 is negative 4. 65 take away 75 is negative 10. 72 take away 75 is negative 3. 67 take away negative 5 is negative 8. 84 take away 75 is 9. 90 take away 75 is 15. And 80 take away 75 is 5. So that are my differences. So that's step 2. So then step 3 is to square them. And step 4 is to add them up. So I'm going to do, again, I'm going to do that all in one step on my decimals calculator. So I'll show you how I'm doing that. I'm just trying to get my calculator someplace that's maybe useful so I can see. Nope, can't make it small enough. All right, so how I'm going to do that is I'm going to put in each of my values and square them and add them up at the same time. So again, you can do this. So it's really important. I just checked on my calculator and I put in negative 14 squared and I ended up with a negative number, which is not true. Negative 14 times negative 14 should be positive. So that's just how my calculator is working. So it's important that I put in it in brackets in order to make sure that it actually squares to negative 14. Oops. So you have to make sure your calculator is doing what you actually want it to do. So negative 14 squared plus 8 squared plus 2 squared plus 13 squared plus negative 8 squared plus negative 4 squared plus negative 10 squared plus negative 3 squared plus negative 8 squared plus my calculator 9 squared plus 15 squared plus 5 squared equals 1017. So that's so adding up all the squares is equal to 1017, right? That's what it was. Yeah, 1017. So then step 5, divide by, and we have 12 points. So 12 take away 1. So divide by 11. So 1017 divided by 11. So you're going to have to figure out how to organize your information. I'm not doing it in the most beautiful way. So you need to figure out what makes sense to you. So 10 equals 92.4. We wanted the nearest dollar, so 92. So the variance is $92. So our range was up in 29. Our variance is 92. Okay. And then part C is going to be calculating the standard deviation of, sorry, my computer's not liking me today. It just decided to kick me out of my PowerPoint. Okay, so the standard deviation is what we want to calculate. Our step 1 of calculating standard deviation was to find the variance. We know the variance is 92. So the standard deviation is equal to the square root of 92. So the square root of 92 is equal to 9.59. So 10, if we round it up, it's equal to approximately $10. So the standard deviation is $10. So it ranges about $10 from the mean in terms of the cost of gas, is what that means. So again, the variance at our level isn't really super useful, but it's a stepping stone to figure out the standard deviation, which gives us a little bit more, something that makes more sense. All right, question 2. A bowling team needs one more person. Eileen and Ingrid are being considered for the spot. They both have the same mean score, but Ingrid's scores have a lower standard deviation than Eileen's scores. Which person should be chosen and why? So let's think about this with some numbers to help us give us context. So say, oh, I don't know how, I'm going to pick random numbers because I don't know bowling, what my numbers would make sense. So if Eileen's bowling score consistent as the mean is 100 and the standard deviation is 5, but Ingrid's score mean is also 100, but the standard deviation is 20, then that means that fairly consistently Eileen bowls between 95 and 105, whereas Ingrid bowls between 80 and 120. Again, sorry if these makes no sense. I don't know about bowling scores. So who would we choose? I think it makes more sense to choose Eileen because her scores are more consistent. So though she doesn't get high as often, she doesn't get low as often. So that's what I would make, the choice that I would make. If you would choose something differently, that is fine, just as long as you can justify why. maybe you know more about bowling than I do. So having a lower variability or lower standard deviation means that her scores are more consistent. And now I'm spelling things wrong. So I would choose her. Would choose Eileen. All right. 3, calculate the range, variance, and standard deviation for the points scored at the home games for a basketball team. So we have 100, 105, 101, 103, 100, 99, 102, 98. So the range is our highest value, which is 105. Take away our lowest value, which is 98. So that I would say, well, if I going from 105 down to 100 is 5, then down another 2, 7. So that range is 7 points. So then the variance, we need to figure out the mean. So as you can see, figuring out the variance takes some work, takes a bit of time. So we have 100 plus 105 plus 101 plus 103 plus 100 plus 99 plus 102 plus 98 equals 88. No, sorry, 808. 1, 2, 3, 4, 5, 6, 7, 8 divided by, so 808 divided by 8 is equals 101. So our mean is 101. So then to figure out our variance, we now need to figure out the differences. So again, I'm just going to write it here. So the difference between 100 and 101 is -1. The difference between 105 and 101 is 4. The difference between 101 and 101 is 0. 103 and 101 is 2. 100 and 101 is -1. 99 and 101 is -2. 102 and 101 is 1. And 98 and 101 is -3. Next thing we need to do is for variance is we add up the squares of our differences. So again, I'm just going to do that on the calculator. Clear all that. So we have -1 squared plus 4 squared plus 0 squared plus 2 squared plus -1 squared plus -2 squared plus 1 squared plus -3 squared equals 36. So sum of our differences squared equals 36. So then we need to do, so our variance is equal to 36 divided by, remember we have 8 data points. So 8 minus 1 is 7. So 36 divided by 7 equals 5.14. So our variance is equal to 5. And then our standard deviation is equal to the square root of 5, which is equal to 5, is equal to 2.2, or we'll just say 2. So our points for our basketball team range about 2 points per game from the mean, which makes sense. All of our points were really close together. All right, there we go. Another practice of doing it. Doing the table is totally great. If that works for you, just doing it on a calculator works fine too. As you've done the practice, you figure out what works best for you. All right, one last question. Cole's math test scores have a mean of 81% and a standard deviation of 5%. Daya's scores have a mean of 84% with a standard deviation of 10%. Whose test scores are more consistent? So again, we have Cole has a mean of 81% and a standard deviation 5%. So that means that their scores range from 76% to 86%. And Daya's is a mean of 84% and a standard deviation of 10%. So their scores range from 74% to 94% in general, not precisely exactly, but in general. So whose test scores are more consistent? Well, Cole has a smaller standard deviation, so their scores are more consistent. You can see that between 76 and 86 is smaller than between 74 and 94. And that's how you can use standard deviation to find that variability. And that's why it's useful information. There you go. That's all that we need to do for that question. Great, so that's standard deviation, variance, and range. I know that they can be a little bit confusing as to how they're useful. I know variance doesn't seem super useful for our purposes, but it helps us get to the standard deviation, which does give us information that is useful. So you do need to practice doing them both because you need the variance to do the standard deviation. If you are having any questions or concerns, please contact me as always. You can call and leave a message for me at the office and I'll get back to you at 807-737-1488 or 1-800-667-3703. You can email me any questions that you have. You can send me some of your work and I can help you along if that would be useful. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. My Facebook is bslate Wahsa and my YouTube is also bslate Wahsa, where this will be uploaded this afternoon. So you can go back and see a replay of calculating all those steps for variance if you need to. There's a lot of parts, so it makes sense that you might need to spend some time to redo that. My office hours are Monday through Friday, 8 a.m. to 2 p.m. If you need to connect with me, I can get back to you most quickly within those hours. Have a lovely day. Good luck with calculating variance. I hope that it can make sense for you. And thanks so much for joining me. Miigwech.